those mobile launch platforms, which extends over the top in every direction, many feet. On the left-hand corner over there, you see a glass enclosed compartment. By the way, you on the left have your opportunity to photograph. Coming back, you on the right will have your chance. We'll go by it again. The glass enclosed compartment would house the drivers, of which maybe there would be 6 or 7 engineers. Walking along outside would be 8 or 18 to 20 engineers, making sure those treads were working correctly. You wanted to go in the other direction, they would come out and get into this glass enclosed compartment to go that way. No U-turns for this vehicle. It would have to sit anywhere otherwise. It traveled at 1 mile an hour, as they said, loaded, but this next launch will probably be so heavy, yeah, they'll be lucky they get up to a half mile an hour. We'll talk more about that as we go along.
Launch pad to VAB trip time with the mobile launch platform is about 5 hours. When operated, it takes about 18 to 20 technicians and 7 engineers to move it along the crawlerway. So many trips, the crawler has racked up more than 3,400 miles. The crawler transporters are powered by 16 traction motors, powered by 4 1,000 kilowatt generators, driven by 2 2,750 horsepower diesel engines. 2 750 kilowatt generators, driven by 2 1,065 horsepower diesel engines, are used for jacking, steering, lighting, and ventilating, and gives an average gas mileage of 32 feet per gallon. In the future, the crawler transporters will be used for the eventual NASA Space Launch Systems SLS heavy lift vehicles, as well as various commercial launch systems.
Okay, and there it is, ladies and gentlemen. That's what it's going to look like. It is a combination of both of our programs with a single stick for promoting quite a bit of thrust and 2 solid boosters from the shuttle program added to that stick to make up the whole new generation, making it, again, the most powerful rocket yet launched from America. As I said before, it will altogether generate 8.9 million pounds of thrust at liftoff. Well, here we are at Launch Pad A, and the history here is extensive. First of all, it is now being used by SpaceX under a 20-year lease agreement to launch the Falcon rocket to the space station, delivering not only payloads like they are currently doing with a smaller Falcon rocket, but will also be able to deliver people and payload to the space station in the very near future. We're talking maybe 2 years. That will relieve us of the possibility of having to rely on Russia for the next 2 decades to get to the space station. Talk more about that in just a moment. Okay, now that's what's happened here at Pad A, but also at Pad A. Pad A was the site of our moon landing launches. All 12 Americans who walked on the moon left for this launch pad right here, way back there between 1969 and 72. 6 separate landings with the Saturn V moon rocket. And now then, this tower you see right now here was put up here for the shuttle launches that were flown from here between 1981 and 2011. And it has been the major launch pad, of course, for the last 5 decades. Consequently, we're very proud of Pad A, but once again, we won't be using it in the future for NASA. Once again, SpaceX is a private company and contracted by various other companies to deliver payloads and NASA to the space station. So, we have here the service tower for the shuttle launches, and it's the only one left. SpaceX decided not to remove it. They didn't need to. So you're looking at 2 parts of that tower. You see the lightning mast at the top of the right side of the tower. That is built permanently in place. It does not move. Part of the tower to the left, however, does swing around to cover up the orbit, and when it sits out here at the pad as part of the shuttle. Once again, pads A and B for 30 years looked alike. Looked like this with the shuttle support. But Pad B, well, we'll talk more about that as we get over there in just a couple of minutes. Pad B has been changed, although they also launch shuttle launches. To your right, you see Complex 41, 40, and 37. 41, Atlas. 40, SpaceX with a small Falcon rocket just to deliver supplies to the space station, and 37 for the Delta launch that flew just this last week. And of course, it will be phased out eventually, but that is the one that, of course, delivered our GPS systems to Earth orbit for you to enjoy, knowing where you're going on your mobile type systems on your automobiles. And of course, they want to have all of them completed for the circling the Earth so that we can be able to go anywhere with knowing where we're going. So that's down the road, but Delta is being phased out eventually, and we'll be back to Atlas for most of the military launches. They will be unmanned for the most part. To the front of the bus, over the dune, the ocean. We're very close out here. The object being, of course, to always launch over an unpopulated area, which of course means that we launch from west to east. By launching from west to east, we gain about 600 miles per hour. We gain about 600 miles per hour from the rotation of the Earth in launching a vehicle, so it helps to launch here close to the equator. And of course, farther down you go, it's even better. Right around, I guess, right about the equatorial plane, it's about 800 miles per hour. To the front of the bus again and left. Over there, next to that tall tower with the lightning mast, of another gray tower, and that is the water tower, holding 300,000 gallons of water. Water is used as a deluge muffling system, not so much as cooling, but to weigh the platform down from the vibrations and shock waves during the launch of a shuttle. The shuttle's three main liquid engines are ignited about 10 to 12 seconds prior to the solid boosters, and they take a few seconds to build up to maximum thrust. In the process, the shuttle sits there lashed down to that platform, banging, shaking, and rattling away. Those tiles could get dislodged, so they use the water to flood the surface of the platform, allowing the weight of the water to weigh it down and muffle the shock waves and vibrations. In order for the water to do its job, they dump the entire 300,000 gallons of water across the platform within 20 seconds. It's a gravity feed drop through an 8-foot in diameter pipe, flooding over the surface and flowing down into the flame trench, so that much what you see out here is not smoke so much as steam. And of course, that's from those hot engines hitting the water as they are ejected into the pad and then out away from the launch pad through the flame trench that has a 42 feet deep slope in it. And of course, that allows the blast to be ejected away from the pad up into the air. The water deluge system was important to making sure the safety of not only the crew members inside, but also the fragile parts on the shuttle, such as those tiles. Once again, 135 shuttle launches from each launch pad here together. They split them up. I think there were about 82 from A and the balance from Pad B. Pad B, of course, had the service tower like the one in Pad A. But about 8-9 years ago, they tore down the tower to get ready for our next generation of launches. And of course, the next generation of launches, like you saw the tower back near the Vehicle Assembly Building, will be carried out here on the platform by the crawler to the launch pad. So we do not need the service tower here at the pad for the next generation of launches, just as we did not need it for the Apollo program either, for the moon launches. You see these three tall lightning masts, 600 feet tall, the tallest yet here in the Space Coast. We have a problem with lightning with tall metal objects pointing to the sky, so they even have the tallest lightning mast that we've had yet out here to help protect the rockets at the pad. And we have a tall rocket, of course, that will be brought out here for that launch. Please notice the wires at the top that to help defray the lightning blasts away from the pad. And to the right, of course, we have another water tower. Again, full water deluge system. You will see another bubble-type storage tank to the right. There's a second one on the opposite side for the supercold liquefied hydrogen, supercold liquefied oxygen that will be loaded for the liquid engines aboard the spacecraft. To the right, you see a low ramp here with some little short mounts on them Those are for closed-circuit television and still cameras. You use between 100 and 125 out here to monitor the events during the launch, so they know exactly what's happening at the pad and are looking for any anomalies to occur. There are other cameras throughout Kennedy Space Center on top of the VAB, out of the runways. Please notice the fences on your right. Please notice that they are curved out, that's so the alligators cannot get in. They can climb a 6-foot fence, but they can't climb something that goes down to a curve, not allowing them to get to the top and get over. Once again, this is Pad B, Pad A on your left, Pad B here too in our presence. All at Complex 39 at Kennedy Space Center. This is another pond where we sometimes see alligators. They kind of laugh about that, I think, because this door that they have in this building is an automatic door opener. And guess what?
Yeah.
The gators found it too. They have some surprises in the morning when they come out and find a gator in the hallway. Keeping cool and keeping warm, whichever the case might be. Okay, nothing there, nothing on your left. I will pull here to the right, and you'll be freed, if you like, to walk around the bus. I cannot let you off. To photograph this launch pad. This will be the future for our next generation of launches. Space launch systems to Mars or maybe the asteroids.